All right, so we are going to move into inequalities. So when we look at what is an inequality, well, an inequality is when we compare one expression to another. Okay, so for example, we might have like x is greater than 4, right? I'm comparing x to the number 4. X is greater than 4. When we talk about a solution of inequality, it's a value that satisfies the inequality. And when I say satisfies, what I mean is it makes it true. So looking at my example, x is greater than 4, one solution of the inequality would be 5. Another one could be 7. Another one could be 92, right? It's just a solution of the inequality. I'm going to try to recalibrate this here quick because it wasn't quite doing what I wanted it to. Let's see if this helps. Okay. So that is, let's move this over. That is the solution of an inequality. My solution set then is all values that make the inequality true. So in this example, my solution set in x is greater than 4, my solution set is all values, all values greater than 4. Now, is 4 going to be included in this set? It is not going to be included in this set because it's just greater than 4. So one of my solutions to this could be 4.000001, right? It's super, super close to 4, but it's not 4. So this would still be part of my solution set. There's 4 different signs that we talk about when we look at inequalities. This first one is less than. Another way that you might see it is fewer than. And when we talk about graphing, it says fewer than. When we talk about graphing inequalities, we graph them on a number line, okay? So for this example, my x was greater than 4, so there's my 4. If I were to graph this, I would put an open dot. It's not working, there we go. An open dot on the number 4, and then an arrow pointing to the right. It's everything greater than 4. So if I use the sign less than, it's not including 4, so this is going to be an open dot. If that's less than, that means this guy is greater than. You may see more than. This one is also an open dot. It does not include the value. Our next one is less than or equal to. if we have less than or equal to, you might say, you might hear at most. It's at most this number, and you might hear no more than. Now, less than or equal to means that I am including the value that I'm talking about. So if I'm graphing this one, this will be a closed dot. Okay, greater than or equal to is our last one. You might hear at least. It's at least this number. Or no less than. Okay, this one is also going to be a closed dot when we graph it. All right, we're going to look at a couple examples. So I'm going to write an inequality for each statement and then quickly sketch the graph that makes each inequality true. So the temperature T in Sweden is at least negative 10 degrees Celsius. I'm going to start with my variable, which I know is T. So T is at least, well, if I look up here, at least says that it needs to be greater than or equal to. T is going to be greater than or equal to negative 10. If I were to graph this, here's my number line. I'm going to start down here at negative, 14, negative 12, negative 10, 8. Okay. Greater than or equal to means that I'm going to use a closed dot. So I'm going to put a closed dot on 10. Greater than or equal to means that my arrow points to the right. That is my graph. The elevation E of Alabama is at most 2,407 feet. So my inequality is going to look like this. E, my elevation is at most. If I look up here, at most is less than or equal to, at most, 2,407 feet. If I were to graph this on a number line, right, it'll be a closed dot because it's at most, it's less than or equal to. My arrow is going to point to the left. That's not a very good arrow, but you know what I mean. Okay, my arrow will point to the left. Okay, so now we're going to look at each graph and write an inequality from the graph itself. So this first one, I'm going to use the variable x. X is kind of what we use just generically when we talk about variables. So I'm going to say my variable x, closed dot, which means that I need at least an equal to somewhere. It's going to the right, which means that x will be greater than or equal to 1. Open dot, that means that instead of it being greater than or equal to, I'm just going to have x is greater than 1. Doesn't include 1, but it is greater than 1. Next one, I've got a closed dot, so I know that it's going to be another equals to, pointing to the left, so it'll be less than, So we're going to say x is less than, x is less than or equal to 1. Last one, I've got an open dot. X is just less than 1. Okay? Just a couple more here. So I'm going to write each sentence as an inequality. So I'm going to look at what the sentence says, and I'm going to write an inequality from it. So my first one, 12, is greater than or equal to 5 times the number n. So I'm going to start with 12. I've got greater than or equal to 5 times the number n. So 5 times n. 12 is greater than or equal to 5n. 1/3 of a number h is less than 15. Of means times. 1/3 times h is less than 15. Okay? Then my last one here, I've got 7 is 7 is less than or equal to the difference. Difference means that I'm subtracting. 7 is less than or equal to the difference of a number q and 6. So 7 less than or equal to the difference between a number q and 6. So q minus 6. And then our last ones down here, we're looking at whether or not the value is a solution to our inequality. So this first inequality we have is d minus 7 is less than 12 when d equals 19. So I need to take my value of d and plug it in to my equation here. So it's going to look like this. 19 minus 7, I want to know, is that less than 12? Well, 19 minus 7 is 12, less than 12. So is 12 less than 12? It's not, right? If I have a line through my inequality sign like this, that means not. You've probably seen like this one, it's not equal to. I can do the same thing with my inequality sign. So this says that 12 is not less than 12. This is not a solution to my inequality. Do the same thing over here with n equals 1. So I've got 9 is greater than or equal to, I want to know, is it greater than or equal to 3 times 1 plus 6. So I'm down to 9. It's greater than or equal to 9. Yep, that is true. 9 is greater than or equal to 9. This is a solution to my inequality.